Hello, I'm Darshini, Group Leader of Group 2. Today, we will be presenting on Task 2, estimating the amount of paper needed and its cost such that we can print math textbooks for the entire cohort of Secondary 3. My other members are Tao, Ranqing, Rui, and Celeste.
To start things off, we will be going in depth into understanding the question. Firstly, we have to locate the information given within the question. We found two key points, one being that we had to print the textbook for the entire cohort, and the other being that the pages printed must only use recycled paper. Beforehand, we had to think of some of the key information to accomplish the task. We had to find out the number of students that were in the Secondary 3 cohort, the size of a typical textbook, whether it is A4 or so on, number of pages in the math textbook, and the amount of paper needed to be recycled. To find the number of students in the cohort, we had to use the average number of Secondary 3 students over the last decade to get the answer. Our workings are shown as such. This chart shows the enrollment rate of Secondary 3 students, which helped us to get the answer of 49,870 students on the previous slide. As we were given the task with not much data, some things had to be assumed. We had to assume that each student only buys one textbook. Each textbook has a total of 300 pages. Each piece of paper had the same weight, and that the books were printed in A4 size paper.
We also had to assume that all students were using the same exact textbook. There were no overseas transfer students that came over to Singapore and bought the textbook. Every piece of paper recycled could give us one piece of paper in a 1-to-1 ratio, and that all books were only made from one type of recycled paper, uncoated paper stocks. Next, we had to formulate and devise a plan. We used codes with different meanings to differentiate them. V represents the total number of pages needed. P represents the number of pages in the textbook, and E for the number of students. We use two different ICT tools to aid us in this program, helping us form graphs and charts. They are Microsoft Excel and the Numbers app.
Moving on to the limitations of our strategy, there were quite a number of things that had to be addressed. It may not be possible to reach out to every Singaporean to get them to recycle, as this act needs the help of everyone, with some people not having or not wanting to recycle their spare paper.
With our plan in mind, we came up with a solution. We had to use the approximate number of pages we had in the textbook, which was 300, and divide it by 2 to find the number of papers needed per textbook, since they are printed on both sides of the paper. Then, we multiplied it by the total number of students in the cohort to find out the number of papers we needed for all the textbooks. Next, we could use the cost of printing one piece of paper to find the cost of printing for everyone by multiplying the cost to the total number of students. These are the calculations found for the total weight of the papers that are needed to be printed for the entire Sec 3 cohort. And these calculations were made to find the printing cost of the textbooks. As you can see, we used the cost of printing the papers with a laser printer in bulk and found out how much each textbook costs, helping us to get to the total cost for the Sec 3 cohort in Singapore. However, there were a few constraints with this plan made. Initially, we completely forgot that each paper could be printed on both sides, so our calculations were very big and it caused us to be alarmed. making us change the calculations repeatedly. Recycling prices also vary from different websites, so we had some trouble trying to figure out a trustworthy and reliable source for them. There were also many factors affecting the total result we got, so all our calculations were mostly around estimation.
For the real-world solution or solution A, we found the number of papers each person in Singapore has to recycle, first by using the total number of pages needed for all the textbooks, dividing it by the total population of Singapore. With the number of 2.65, it rounds up to the nearest whole number of 3, meaning that each person in Singapore has to recycle a total of 3 pieces of paper each. For solution B, this is slightly different from solution A. Solution B does not use the entire population of Singapore, which include babies and the elderly, but only working on adults and students. Likewise, we use the total number of paper divided by the total population of working adults and students only, giving us an estimated number of 4 pieces of paper to be recycled by each person. In these 2 slides, it shows our findings and how we got to the final answers.
We prefer solution B as it is more plausible since it is not practical for us to have every individual to recycle a certain amount for us to meet our requirement. It is way more plausible to have only working adults and students contribute, as they are more aware of what recycling is and how to do it, unlike other age groups like toddlers. Next. Reflecting on the real world solution, if it's adequate, solution A is not adequate because we decided to calculate how much each Singaporean should recycle so that we can meet the requirement of printing textbooks for all the secondary students. It might not be practical as we would not be able to get everyone to recycle as it's one's choice to do so. Hence, looking at both solutions A and B, solution B is far more better. Also, since research shows that since the amount of paper recycled in percentage has been decreasing on average over the past few years, indicating that the year 2020 has the least number of recyclables collected, it is not adequate as there's already less and less paper being recycled per year. So this pie chart shows the 2020 waste statistics of paper and cardboard wastes, where the total number of waste generated is more than the total number of waste that has been sent to recycling. Next. So how can the model be improved until an adequate solution has been found? Instead of focusing on each individual and how much each individual should recycle to meet our requirements, we can expect certain companies to recycle a certain amount of waste. Since there are different waste types that can be recycled under paper and cardboard products like food containers, cartons, and newspapers, so involving companies from different fields like milk production, newspaper printing, and so on, these companies coming together and recycling products would contribute to the amount of recyclables collected, which helps with meeting our requirement. Next.
Looking back to our solutions, we can link and extend it to real-life problems like deforestation. By using more recycled paper, the rate of deforestation will be reduced because there will be less cutting down of trees to supply the demand for paper products. This can help to improve sustainability in the long run as there will be more recycled products. Here is all our reflections. Through this program, I learned how to better communicate in groups and learn to apply math knowledge to real life situation. I also learned that teamwork is very important in group work so that we can complete the project in time.
Through this program, I have learned communication skills and worked better with other people, as well as talking to people I didn't really talk to before.
Through this math module, I have learned to communicate better with my group members and listen to their opinions and try to collaborate our ideas together. I also learned that math is not all about solving equations or word problems, and that it can be applied in real-world situations.
These few days of the math modeling program, I have learned many skills along the way that could further equip me with knowledge, some being teamwork and communication skills. We were not able to open up and help one another on the first day of the program, but soon we were able to work as a team and complete the entire project before the deadline.
Through math modeling, I was able to bond with my team members and sharpen my communication skills. I was also able to look at math from different perspectives where it is applied in daily life, such as recycling. I was able to explore and make connections between real life problems and normal day-to-day situations. I have also learned more about recycling and the strategies conducted by other countries while doing my research.
Now we are moving on to the Q&A segment.
Here are some pictures of us working together.
Thank you.